Glad to be here. It's the third time I'm at the Swiss Text, the first time as a speaker, so I guess that's a really cool thing. I'm Rémy Blättler. I'm the CTO of Supertext, a translation agency in Zurich. Maybe you introduce yourself, Rémy.
My name is Jan. It's also my third time at this conference, second time as speaker, and I'm a research assistant here at in Mark's group.
This morning we talk about the project that Supertext did together with the ZHW and Spinning Bytes. It's about term extraction. As a translation agency, the problem we always have if we get new clients is getting a translation memory, for example. And translation memory is all the sentences that have been translated from one language into another. And that helps us in the future to translate faster and to look up existing translations, how did they do this before. On top of that, the terminology is how does this company write certain things now. Every company has a bit different writing. They say this word always has to be translated like this. But if you get a new client and you ask them for these things, they're like, I might ask our old translation agency, normally if they do this, we get nothing or very bad data or like 100 sentences, which is normally useless. So we came up with the idea to scan their website and extract this automatically. So this is a mock-up how it would look like. So you go there, you type in your URL, say start extracting, with the hope that in an hour or two you get a translation memory, you get a terminology. We'll let it run in the background now while I try to explain you the first part on how we try to approach this. The idea first is we need to get the data from the website. And to get the data, web spiders have been around since centuries. That's there. But the problem is, I mean, okay, maybe centuries is a bit okay. Okay, but they've been around. The problem is with new modern websites, they're built in JavaScript. And normal old web spiders, they just get the HTML code. And in the HTML code, if the website is built with JavaScript, you get nothing. So the tricky part was to spider a website and run all the JavaScript and then get the final results, because that's where the data is. And there are tools out there nowadays. One is called Puppeteer, which is built on Chrome. So you're actually running a real Chrome browser that then kind of opens the website and you get the data out of the Chrome browser. Once we got this, we have the structure, we have the data in multiple languages, but it's one big mess because you don't know what belongs together. So we need to align the website. So which website is the German version of this English version? Once we have this, we have to align all the sentences. Which sentence belongs to each other? That's the phrase matching. From there, we get the translation memory. And out of the translation memory again is where we have all the translated sentences. Also, ich gehe nach Zürich. I go to Zurich. That will be one entry in the translation memory. From there, we'll try the term extraction. So if you have a massive translation memory, we'll try to figure out what are the important terms. So the first thing, the web spider, explained it a little bit already. This one it's live. Doesn't look very sexy yet, but it works. But we did run into some problems with this. First problem is speed. If you hit the website with the whole Amazon cloud that you have, the website goes down or they block you. If it goes lower, it takes eternities. So that's kind of like the thing that you have to handle. And then, as always, you build a tool, you put it out there, and you say to people, hey, try it out. And everybody tries it out at the same moment. And because sometimes it takes like up to 5 hours to scan a website, people think, oh, your tool is not running. And then even though we're using this Puppeteer and JavaScript stuff, it just turned out to be a real pain to get good data from JavaScript websites. We had to change our technology like 2 or 3 times in the meantime. Then, how do you match the websites? What do you use? Because the URL, turns out, is normally not something you can use. Officially from Google, there is a recommendation on how you should put in links that say this website, this part, this the English version of this. Turns out maybe 10 or 20% of all websites are doing this. We tried it by the page structure, like how many titles does it have, how does it look like. Worked good for company websites, but for blogs completely fell apart. And then actually the best thing is that we just really try the content. We try the pictures that are in there, numbers, specific words, links, things like this. And I guess the combination of all 3 seem to work reasonably well. Next thing, how do we match the sentences? There's a bunch of tools out there in the market commercially, but most of them seems like it's just not very interesting. They're crap. So we looked at it, what's out there. The simplest version is we just see how long the sentences are, and we just match, like if it's short in French, it's likely short in German. If it's long in French, it's likely long in German. This kind of works. But the results are okay. So I had the genius idea. Let's just translate the German version into French first, and then just compare the 2 French situations. And that works. Turns out my genius idea has long been implemented before, so there it goes. Every time I have a great idea, someone else was quicker. But then it turns out someone else built something even better. It's called the phrase-based matching. I'll explain that in a second. Just to say my idea first. Although it wasn't my idea anymore, but so this is the English. How can I create my own coupon template? You translate this with machine translation. Wie kann ich eine eigene Gutscheinvorlage erstellen? And that's the original German version. So you can see it's fairly close. So matching these 2 is much better than just matching it by length. But it's obviously not the same because we use Couponvorlage and this is Gutscheinvorlage. So if you use a matching algorithm, it might trip over the 2 words that are different, but both results are correct. So the phrase-based matching, that works much better. First of all, you don't need machine translation in the background. You just need to train your system with lots of phrases in multiple languages. And for the translation matching, most of those, they work with the blur score. And the blur score is not very good for long sentences. And this one with the phrase matching, even though if you say Gutscheinvorlage, Couponvorlage, all these things, it uses all variations of each other and still works. So this seems to get the best results. For those who want to know the detail, what Spinning Bytes told me, this phrase-based matching has a better precision, recall, and F1 score. Not that I know what it means, but I trust them. And this is how the GUI, since we do this automatically, but it still needs a human that goes over it at the end. So it's machine presents its ideas, and then the human has to say, okay, this is wrong, this is correct, this is fine, delete this, change something. The biggest problem we had is the false positive. If the machine matches something that the human ignores. Because if you can imagine, you align, let's say you go to Swisscom, you align their website, you have millions or thousands of sentences. And no human can go through all of them. So the human kind of assumes that what the machine prepares is somewhat correct. And then if the machine is unsure, you kind of check the specific cases. But in theory, you fly over it. It's not something you can really check step by step. So we really have to make sure we are on the safe side. Maybe we lose 50% of the content, but that's fine as long as the other 50% is correct. And then, yeah, the matching algorithm was one of the tricky things, but with the phrase-based matching, I think we should be behind this. That was my part. Next part is the term extraction, which Jan will explain.
So now we are at the stage where we have this translation memory, and now I will talk about how to do the term extraction, which is the project that we did together last year. So I called this a story of trade-offs, and I think it's a nice sort of showcase of problems which you will run into if you work with data, and if you work with a bit of messy data. So the scenario we were given is we get 70 translation memories for 70 companies in German and English. So we started with just one pair of languages, and the segmentation was done sentence-wise, as he already has explained. So the goal is to extract terms that are relevant for the company and also unique for the company. So the idea is to know how certain phrases or terms that are very specific to one company are translated within this company, sort of to avoid that one term is translated then into 3 different terms and you get a mess. So one example, just to further clarify, we have these sentences, one in German, one in English. So the German one is das Verwaltungsrat zu Handeln der Generalversammlung, and the English one is by the board of directors to the general meeting. So what we want to have out of these sentences is to match these 2 terms, that this is the translation of this one, and that these 2 terms mean the same in the 2 languages. So this is the goal. Now, there are, of course, a few different obstacles to achieve these goals. And I will go through this in these examples, so from this we can then extrapolate our approach. The first is, terms are not just one word. Oftentimes you have terms that are composed of multiple words that give you a phrase, so in this case, board of directors or general meeting. The second is that not all the words that appear in the text are relevant. So for each language and each company, you need to sort of get the relevant terms. And the last thing, we have to do the matching. Since every sentence has multiple important terms in it, you have to sort of get the matching and not mess that up. So we have this 3-phase approach, which sort of summarizes what I just presented: phrase extraction, then extract important terms, and finally do the term alignment. So for the phrase extraction, we just use a very simple statistic-based approach where we count, where we score each pair of words or phrases and look at how often they appear together, like one after the other, and sort of put that into relation with how often these words or phrases appear by themselves. With the hope that phrases like New York, that they have a high count here, and not so, and well, New York with the word new, the count here will be high, and York will almost always or often appear as often as in conjunction with new, so the score will be high, and other more common phrases will have a low score. So there are 2 parameters that you can set. One is the minimal count that you will want to have here, because having just one example, when you have the count of 1 here, count of 1 there, and count of 1 here, you will have a very high score, but in the essence it could be just one spelling error and you get bad results. The other one is a threshold, just to say at which score you want to say that this is really a phrase. So there we have the first trade-off. So if we use too strict of these parameters, we lose obvious phrases like split flat displays. And if we are too liberal, we get nonsensical phrases like in den letzten, stuff like that. that doesn't really come together. So the second step is term extraction. Now we have all the phrases for each language and each company. So we want to sort of score the phrases by their, how relevant one phrase is for the company. So the idea is we have the full corpus of the 70 companies, and then we look at, we want to have words that are specific for the company. So we look at words that appear often, but they only appear in the context of one company. So what we do is we do the TF-IDIAC scoring, which most of you should know, and we look at how often does the term appear for company D. This is the term frequency, and the document frequency looks at how often, in how many companies this term appears. So this is the document frequency, and we take the inverse of that. And then this is the formula, and at the end we hope to find terms that appear just very often in just one or two companies. This is how we define being important. Again, we have thresholds because we have to sort of set the score. When is term important? If we set it too low, we lose a lot of. If we set it too low, we get a lot of irrelevant words and phrases, and too high, we lose a lot of important phrases. So, an example of what can go wrong is most of the problems come from the phrases, because if you be a bit too liberal, we get a lot of such phrases that have a higher term frequency and a very low document frequency, because they often just appear in one document just out of chance. And then we have these things here being rated as being important. But however, we get a lot of good words, and wind farms is one that has a bit of a higher document frequency and a high term frequency. So we have now the important words, and now we have to do the matching, and we want to avoid having this here, that Generalversammlung is matched to board of directors, and to do this we also use some scoring. We have the same idea as with the phrases. We go through each of the sentence pairs, and we get all the important terms out of these sentences, and then we look at how often these appear together, like the German and the English one. Often do they appear in different sentences, in the hope that this pair here appears often and this pair here doesn't appear as often. And then we again have a score that sort of looks at how well this works. Okay, so we have this three-phase approach, and now of course we are interested in how well this works. Since we don't have any gold data, we cannot put a slide with a lot of scores in there, so we have to do more of a qualitative analysis of this. And this is hand-labeled by supertext. And we have here the green ones that are okay, the yellow ones that are okay, correct, but they need some post-processing. These ones, the blue ones, are irrelevant, and the red one is very bad. And this is a very great example of what can go wrong. So first we have the phraser that puts together so bad, which doesn't make any sense. Then the term extraction says that this is an important term. Well, it makes sense after I explained how it works. And the last thing is, why do they go together? I mean, the phrase matching also failed in this regard. So, but we have also very good one. I'm always a pessimist, and I always show what doesn't work because it's more interesting. Okay, then the idea is now we don't have any gold data, and this is the last slide and also the next step, because we want to get some human annotation. So we take what we have and show it to the translators of supertext, and they rate if it's a good translation, if it's a bad term, if it's relevant or irrelevant. And yeah, I think this is it. Thank you very much.
Thank you for staying in time. We have achieved our first goal here. Now the next goal is to have many questions from the audience.
did you check if you crawl more websites, if the quality improves, and what is the ratio of improving by collecting more websites?
No, at the moment we don't have some kind of learning algorithm that with more website the algorithm gets better. We crawled some websites and checked what are the statistics, and then we decided, okay, I think these are the 3 algorithms we need if we get the best results. But we haven't done a second round and tried to improve it. The idea here is that also with the term extraction, sentence alignment and term extraction, that we get more data, that potentially we can just, that's me, the amateur speaking, just put it into an AI machine and then improve the algorithm. But for that, we just didn't have enough data yet. But with these things, I think we can start collecting data, we can start getting results, and once we have way more stuff, we can do another round and see what can be improved.
For Swiss companies, if you're 70% Swiss companies, I guess there are quite some words which occur for each company, like Generalversammlung and Verwaltungsrat. So you try to track that for each company themselves. So do you also transfer this between these translation members for the companies? And a follow-up maybe, if you detect that one company does kind of a strange translation which differs from all others, do you also inform them and say, hey, you're translating this wrong?
Yes. So sometimes, normally if we realize this, we tell them. More often than not, they either have a reason for doing it like this, or they said, we've done it like this for the last 10 years, we'll keep it, and sometimes they change it. That's pretty individual. But it's, like, as a translation agency, we do not share the translation memories between companies, because that can lead to weird situations when suddenly Coop is using some kind of a slogan for Migros, and that's something we really don't want to happen. So we have individual translation memories for all companies.
There is a program called Animalign, which combines these collocation score that you use with alignment and performs term extraction over parallel data. Have you ever heard of that?
How is it called?
Animalign.
Animalign.
It's like 10 years old.
You did some previous.
That it doesn't ring a bell.
Okay, maybe it's worth a look, because
Yeah.
it's just like just extracting correspondences of phrases in these 2 languages and scoring them according to the lexical rate, to the translation probability, just like what you're calculating, but improving over more material that you feed in. So.
Right. Okay, that sounds interesting. Yeah, I'll have a look afterwards. Yeah, thanks.
Did you, for the term matching, where you show these red results, did you think about using part of speech tagging, maybe check whether both phrases contain at least some content words which might correspond, or do you stick to just the quantitative analysis here?
At the moment, yes, because we didn't want to go into machine learning based approaches, because we could also have done stuff with identity recognition and all these things. However, this approach gives us a very language agnostic solution, and the scope of the project didn't allow to train taggers and evaluate taggers for each language, because you would have to do this for each language, because German and English was just one sentence, one pair of languages, but we have 6 languages and all pairs of these languages, and the scope of the project didn't allow to sort of delve into all these machine learning approaches. Because for the sentence alignment, you can also think about using some alignment tool that sort of puts the the phrases into the same position, and then it makes the translation easier. But we couldn't try these things out.
I'm a bit irritated by your answer here because, I mean, for a dozen of so languages, part of speech triggers are freely available, so you don't have to train any of them. So
But we have to evaluate them.
you don't even have to evaluate them because in general purpose text they work very well. I mean, they're definitely able to rule out. But of course, if you want to use more machinery, more systems, then you have additional effort. Maybe a last question? No other questions? I was also a bit worried about copyright issues. I mean, you're downloading anything from the web. Have you thought about copyright issues? But I leave that open for discussions. So maybe move to the next presentation, but first let's thank the speakers.